Right, well, welcome to another video. This one's going to start to look now at something slightly different. So up until this point, what we've actually been doing is we've been looking at sort of processes operating in the hydrological cycle. Now we're going to start actually moving into the sort of factors that affect it over long and short term times. And in particular, what we're going to be looking at today is drought. And so what we're going to look at are the physical causes of drought. We're going to start thinking about human activity and start thinking about how sort of droughts impact people. And actually some of that you're going to be doing for sort of homework. So yeah, we're making good progress and we're going to carry on doing that. So let's get started. The first thing we need to do is we need to think about what the word drought means. And unfortunately, that's not so simple. So you might actually hear the term drought used, or if you go into it in more detail, you'll start to find out the different types of droughts. So there's meteorological droughts, hydrological droughts, agricultural droughts, and famine droughts. So what I want you to do, you should have this sheet in front of you. And what I want you to do is have a look at these, and I want you to match them up with what you think are the correct sort of definition. Okay, and I'll give you a starter. So a shortfall deficiency of water over an extended period of time. That's particularly an unusual shortfall deficiency of water over an extended period of time. Okay, is your definition of a drought. So there's your starter for 10. You need to match up the other 4. So stop the video. When you're happy with what you've got, let's see if you've got it right. Okay, so let's see what you got then. So hopefully you match them up like this. Now you'll notice I've sort of tried to put them in some sort of sensible order here. So we start off with drought. And as I said, any unusual shortfall or deficiency of water. Now, the word unusual is quite important because we live in Britain, it's a pretty wet country. If we go actually a couple of weeks without rain, that's really unusual. If you live in the Sahara Desert, on the other example, actually going 9, 10, 12 months without rain isn't unusual. So just because it's dry doesn't mean that it's actually a drought. It's that change from normal that makes it a drought. Now, actually, that's not a particularly helpful definition. It is a sort of what we use at GCSE. At A level, what we need to know is we need to think about these 4 things. And so the way we're classifying drought now is by, if you like, its effects. So to start off, the simplest definition is a meteorological drought. It basically is dry. There isn't a huge amount of difference between the sort of GCSE definition and meteorological. Okay, we're talking here about a lack of rain that is perhaps unusual. It's going to often be associated with high temperatures, high rates of evaporation, and basically you've got that lack of water, okay, or lack of rain. And it's not talking about any other impacts, it's merely there's a lack of rain. Now, if there's a large amount of rain, and eventually what's going to start happening is you're going to start noticing that rivers, for example, start flowing less fast or dry up altogether. The groundwater will start to drop. Maybe you've got sort of wetlands and other habitats badly affected at this point. You might have to start having hosepipe bans, things like that. Now, what we're talking about here is a drought that is impacting water, the hydrological processes. So we call that a hydrological drought. Now, if that gets worse, and suddenly you've got less water in the ground, there's less water for irrigation, there's less water in rivers, what you're going to start to see is that actually that starts to have a massive impact on agriculture. Now, where you start having problems with agriculture, okay, crop yields go down, cattle might start struggling, may even die. What you're starting to do now is you're starting to see the impacts on food supply, and we call that an agricultural drought. An agricultural drought is not good, but what happens if it gets worse? If it gets worse, what you end up with is what we call a famine drought. And this is the sort of large scale, massive impact. Farm systems collapse completely. People are migrating from the countryside to cities. You might well need international aid at this point. Thousands or millions of people may actually be at risk of malnutrition. So you can see there's this sort of progression as we go through the different definitions. So meteorological drought is just the absence of rain. Hydrological drought is when the absence of rain starts to affect water supply and groundwater. Agriculture drought is when basically that groundwater and river supply means there's less food production, and famine is when that food production starts affecting people and you start getting real hunger. So you've got that sort of process to go through. So make sure you've got that in your notes, okay? And then let's move on. Let's think about taking that a little bit further. So again, you should have this diagram um, in your, I'll email it to you. And all I want you to do is just think about, we've talked about meteorological, hydrological, agricultural, famine, droughts. We've talked about what the images are, the sort of features of it, if you like. What are the impacts going to be? Have a think and see if you can answer those questions. You might want to just do it in pencil at this point, and we'll go through the answers. So in meteorological drought, what's going to happen to soil moisture? What's going to happen on irrigation? You know, by hydrological drought, what's going to happen to water supply? What's going to happen to hydroelectric power? What's going to happen to wetlands? So just see if you can think about those impacts. So stop the video, get your pencil out, have a quick go at those, and we'll go through the answers. Okay, so this is when eventually you get the textbook, this is what you'll actually see. So just have a look at this section here and see if there's, there shouldn't be anything there that comes as a massive surprise, but see if you need to add anything into your diagram. Okay. Right, so you've got that. There's a couple of things we need to just quickly talk about. So one is, how do we measure drought? So we talked about the fact that drought can mean different things. It can mean a lack of water. It can mean a lack of water for farmers. It can basically mean a lack of water for rivers. And so there are three different ways where people have basically tried to measure drought. And you just quickly need to take some notes on this. So you've got the Palmer Drought Severity Index, and that's really focusing on the scale of the drought. So it's looking at the weather associated with the drought. How long has there been a lack of rain? How intense has that lack of rain been? Okay, how much evaporation has there been? It's focused on aspects like that. The Crop Moisture Index is really looking at soil moisture. So it's looking at that sort of, if you like, agricultural drought. It's looking at the amount of moisture available for farmers. And lastly, the Palmer Hydrological Drought Index measures the amount of water that's flowing through the hydrological cycle in rivers and groundwater. So each of these are a slightly different way of measuring it. And it represents the fact that drought means different things to different people. So you just need to finish taking some notes down. And when you're ready, you've got that done. So press pause for now. And when you're ready, press play. Okay, so the one big concept we need to get our head around here is the El Nino. It's sometimes known as the El Nino or the Southern Oscillation, and sometimes shortened as the ENSO. And it is an example of what we call a teleconnection. And a teleconnection is basically where a weather system in one part of the world is so big that it impacts the rest of the world. So for example, with El Nino, we know that an El Nino happening in the Pacific will have massive implications in India, for example, completely different continent, completely different ocean, but that we know that El Ninos cause the failure of the monsoon in India and have been responsible for famines that have killed millions of people. And that's what we mean by teleconnection. So you just need to make sure you've got that definition of what a teleconnection is. And of all the teleconnections in our planet, El Nino is the biggest one. So we need to look at this. So what I'm going to do is I'm going to talk through and explain what we mean by El Nino. Now, there's actually three systems that goes on in the Pacific. There's the normal system, and I'll talk through that in a second. Then there's El Nino, and you can see these arrows are going in reverse. And then actually what there isn't in this diagram, which I probably should add in, is something called La Nina, L-A-N-A-N-A. N-A-N-A, yeah, La Nina. And La Nina is normal, okay, but on sort of steroids. It's super normal, if you like. And it tends to go in this pattern over 5 to 10 years, normal El Nino, La Nina, normal El Nino, La Nina. And you've got that sort of continuing pattern. What we need to do is we need to look at what happens in El Nino and what happens in La Nina and normal conditions in a bit more detail. So let's start off by looking at normal conditions. So this diagram is showing you what's happening in normal conditions. Let's get my pen out here and let's have a look. Let's first of all let's deal with what the air is doing. Now, in normal conditions, what's happening is air is rising over Australia. You've got low pressure, okay? The air's rising. As it rises, you can see here, you've got a little pitter-patter of rain because you've got low pressure over here. Now, over South America, on the other hand, you've got high pressure. And that means air's sinking. And where air sinks, it's getting warmer, therefore it can hold more moisture, so there's very little rain. So in South America, you're going to get very dry conditions. Why I say this, for example, the Atacama Desert's there, one of the driest deserts in the world. Over Australia, Indonesia, the Philippines, you've got air rising, you've got air cooling, condensing, and you've got it forming rain. And if you've got air rising here and you've got air sinking here, well, naturally what's going to happen is that the air is going to move like this. Now notice at sea level, what the air is doing is it's moving across the Pacific Ocean. And that, you have to forgive my drawing here, acts like a bulldozer. Here's my bulldozer. And that bulldozer is going to basically push the water this way. And have a look, all of this warm water here, okay, this light blue water represents warm water, is being pushed this way. And then cold water, which is below the dark blue, just change the colour of the pen. That's a nice dark blue. This water is going, to blue. Oh well. This water, honestly, it's blue, it's cold. It's rising here. Now this line here between the warm water that's going to Australia and the cold water that's rising near South America, it's called a thermocline. And a thermocline is basically a line of equal temperature. And what you'll see is that near South America, the cold water is near the surface, and in Australia it's really deep. And that hot, warm water Australia, that will heat the air up, that makes the air rise and makes it more rain. And you've got a self-perpetuating system. Warm water off the coast of Australia causes warm air rises, causes rain, and low pressure. Low pressure moves to high pressure, and so it carries on. Now, a couple of things. Rain is really good for growing crops. So Australia is going to have loads of crops growing. Here's me trying to draw crops growing. You can tell why I'm not an art teacher. But cold water is really good for fish. So you have loads of fish off the coast of South America. It's where you get your anchovies from if you like those on your pizza. So normal conditions, everyone's happy. Okay, Australia gets loads of rain, really good for farming. South America's got loads of fish, really good for fishing, and it's dry, and that's what happens in normal conditions. However, now in El Nino situations, everything changes. So now what we've got is instead of there being low pressure over Australia, we've now got high pressure. And high pressure means the air is sinking, and it means that there's no cloud. Remember, as the air sinks, it gets warmer. It's meant to be the sun. Should probably make it yellow, shouldn't I really? So high pressure basically means that the air sinks, warms, can hold more water, no cloud forms. However, over South America, what you've got is warm air rising. You've got low pressure. So now you've got the reverse. So now air is rising over South America. That again is going to cause rain. And again, we've got this cycle. We've got this air rising over here, goes across the Pacific. And then on the surface of the Pacific, this time the air is actually moving from Australia to South America. And what that means is that we get our bulldozer again, still can't draw. Here's our bulldozer, and that is going to push the warm water this way. Now, why this happens, we don't know. We think it's probably linked to sort of storms triggering a reversal, perhaps over by South America, Tahiti, places like that. But what's the consequences of this? Well, over in Australia now, you're going to have a drought. So you've got, instead of lots of good land for farming, you've now got a dead cow or something similar, because the cow, the cattle, and all of that have died. Over in South America, well, their cold water's gone. So actually, the problem they've got is that cold water is really nutrient rich and good for fish, Oh, that's gone and been replaced by warm water. So I'm afraid the fish have died. So you've now got a load of dead fish. You've also got huge amounts of rain, so you're going to get floods over here. And those floods, by the way, they won't just be South America. It'll be sort of, I can't write with this. It'll be California and places like that. So this is what's happening in El Nino. And this, which is responsible for droughts in Australia and other parts of the world. But it's also a teleconnection. So this can have a massive impact. For example, we know that the warm water in really extreme El Ninos will go round South America and start killing off penguins and things like that in the Falkland Isles. We know that this will affect the monsoons in India. It will affect droughts in Africa. So this is the single largest factor affecting the weather in the planet other than the seasons. Now, it's really important you understand this. Okay, so hopefully that's explained. What do you need to do? Well, you're going to basically do some research for me. I'm going to give you a fact sheet. I'll give you some articles. The links are here. I'll email you them to them as well. What you're going to do is you're going to fill in this sheet for me. So you need to explain how El Nino works. You need to answer those questions. You need to take some facts down about some examples. So Southern and Eastern Africa, Papua New Guinea, how it causes drought in Australia and other places, and other sort of hazards around the world. And you'll get most of that from the Guardian articles. So your first job is to fill that in. That's about El Nino in general. But there's also a really important case study, and that's Australia. And Australia suffered from something called the Big Dry. So sort of 12, 13-year-old drought. In fact, more than that even, 16-year drought. And it's the longest, hardest drought that Australia's faced. And your job is to create your own geofact sheet. So use the example I'm sending you about El Nino. And what I want you to do is create your own geofact sheet, 2 to 4 pages in length. Okay, it needs to be set out like a geofact sheet. It needs to make sure it includes the following. I need to know the weather associated with the drought. So I don't just need to know it's dry, how bad was it? What percentage of rainfall did they get? Things like that. You need to explain the physical and the human causes. So the key physical factor here is obviously El Nino. You need to make sure you're clear how El Nino drove the drought, but also the human impacts, over extraction of water, poor farming techniques, for example, climate change. You do need to look at the economic, social and environmental effects, and you might want to think small scale and large scale. Economic, how much did this cost? Social, what were the impacts on water supply? That's a really sad fact, is that there was a massive increase in suicides of farmers, for example. They were under that much pressure. What happened to some of the small sort of communities there? Environmental, what happened to the rivers? What happened to the ecosystems? What happened to so endangered animals? There's huge amounts there. There's also lots of management. So what was done at a sort of state and government level, things like dams, desalination plants, setting up river management, but also small scale. What can farmers do? The use of drip irrigation, the use of drought-resistant crops, water meters and water hosepipe bans and things like that. And your job is to make it as interesting as possible, and that means maps and diagrams. So you should aim to use as many of those as possible. So that's your big homework task. Okay, that should take you a good couple of hours easily, probably more than that. But Australia is a really important case study. You've sort of got 3 sections of a case study here. You've got the causes, effects, and management, but it needs to be quality. So have a go at that. When you've got that done, okay, it'd be interesting to see your sort of geofact sheet. So if you can email them to me, that'd be great. If you're stuck or you're not sure about anything, email me. And I hope to talk to you next week. Cheers.